This whole Unit 8 has to do with new and exciting ways of integrating functions. We've spent a good deal of time talking about integration techniques, but we're still fairly limited to what we can actually take the antiderivative of. And integration by parts is a huge step towards opening up the door to new functions. Integration by parts is often thought of as the opposite of the product rule, because if we start off with the product rule, the derivative with respect to x of u times v equals u times dv dx plus v times du dx, we can actually integrate both sides of this equation with respect to x. And, well, on the left side, if you take the integral of a derivative, then they cancel each other out, and we get the product uv. And then if we take the integral of this with respect to x, we're going to take the integral of u, and then the dv sticks around, right? The dx cancels out with the other dx. And then same thing with this next one, it's going to be v du, loosely speaking. At any rate, so that's an equation that we can actually solve for one of the two integrals. Arbitrarily, we pick the first one and leave the other two on the other side. So when we subtract this over to here, we get u times v minus the integral of v du. And that's the integration by parts formula. So what? It doesn't look very useful, does it? It's just kind of this random thing. But if we're tasked to try to take the antiderivative of u dv, and we happen to not be able to do that directly, but we can actually figure out what v du might be, and we can actually integrate that one easier, then we're making progress. So here's an example. We've got the integral of x times the cosine of x dx. That does not look like a very complicated expression, but using processes that we've already learned, I don't think we're going to find a way to find the antiderivative of this. So let's give this this integration by parts a try. So the first step is we have to determine what u and dv are. So this integral right here is this integral right here. So x cosine x dx is equal to u dv. And we can pick and choose what belongs to u and what belongs to dv. The only choice we don't have is that, let's scroll back up a little bit. Come on, computer. There we go. The only choice we don't have is that the differential dv and the differential dx have to be in the same equation. So I guaranteed have to have a dx here. Now it's possible that's the only thing I have here, and then the x times the cosine of x goes over here. Or we could put just the x here and put the cosine of x over here with the dx. Or we could put the cosine of x here and the x here. So there are lots of different possibilities for what we can do. So how do we know what to pick? Well, if you don't know what to pick, then just try something and see where it takes you. And we'll talk about where we go once we make that decision, where we will be taken. But here's a good rule of thumb. We know that we're going to, once we set a value for u, we're going to have to figure out what du is by differentiating. And once we pick a value for dv, we're going to have to find a v value by integrating, right? So different directions. We want to make sure that when we take the derivative of u, it gets simpler, or at the very least, it doesn't get more complicated. Same thing with dv. We're going to integrate something that either gets simpler or at the very least doesn't get more complicated. So if I tried to put a cosine of x here, well, that's easy to take the derivative of. You just get negative sine of x dx. That's no worries. But then if we put an x here, taking the antiderivative of that would be 1/2 x squared. This did not get more complicated, but it also didn't get simpler. This definitely got more complicated. Our exponent of 1 went up to 2. So that's not going to help us. We don't want things to get more complicated when we do the integration by parts. We want things to get less complicated. So let's try to do a little switcheroo here. And we'll put the cosine of x over here with the dx. And we'll put the x over here. Now the derivative of x is just 1 dx. We're taking the derivative with respect to x, right? Du dx equals 1 or du equals dx. So that's definitely simpler, right? 1 is simpler than x. And when we take the antiderivative of cosine, we get sine. Well, that didn't get worse at the very least. So this got easier and this got no different. So that's a compelling choice for the values. So once we know what u and dv and du and v are, then we can apply the integration by parts formula. It says u times v minus the integral of v du. So, oh yeah, here we go. So u dv equals u times v minus the integral of v du. So that means that the integral of x cosine x dx, using these values up here for u and dv, well, let's see, we start with u times v, which is x times sine of x times sine of x, minus the integral of v du. Well, let's see what v du is. V is sine of x, and du is dx. So we're going to put sine of x dx. All right, well, so this is a new expression that equals our original expression, but take a look. This part is done because it's not in an integral. We've gotten that part out of the integral. And then this next part, well, it's still an integral that we have to worry about, but it's an easy integral, right? It's just sine of x. We know how to take the antiderivative of the sine of x, so that x sine x stays the same. And then we're going to subtract the antiderivative of the sine of x. So negative cosine of x is what differentiates to positive sine of x. And then, of course, this is an indefinite integral, so we put our plus c there. And then we can simplify this by saying minus a negative is the same as plus. So that should be our final answer. We think it is, and we can always check this by taking the derivative, right? So that's not a bad idea at all. Let's see what happens when you take the derivative with respect to x of the answer, x times the sine of x plus the cosine of x. Give that a try. We can put the plus c there if it makes us happy. The derivative of c is, of course, 0. So we've got a product rule. We've got 1 times the sine of x plus x times the cosine of x. That's the uv prime plus uv prime. Plus cosine of x, we're going to differentiate the cosine of x to get negative sine of x. Plus c means we're going to differentiate that to 0. So we've got a positive sine of x, we've got a negative sine of x. Those are gone. The only thing that's left is exactly what we were hoping would be left, the x cosine of x, which we started with. So that means that the antiderivative that we found up here must be correct. We checked it. Hooray. So that is the basic idea of integration by parts. And in the next video, we'll try a few of these examples, but you should go ahead and try them now and see how they go, and then check your work in the next video.